Hi, welcome to the discussions on the solutions of the JEE main papers. In this part, we shall be taking up the paper which was conducted on the 5th of September in the evening slot, and the subject we are discussing is physics. Let's start with question number 1. Question 1 says a spaceship in space sweeps stationary interplanetary dust. As a result, its mass increases at a rate dm by dt equal to bv square. V of course is a function of t, and the question says Vt is its instantaneous velocity. The instantaneous acceleration of the satellite is, well, the question is about conservation of linear momentum, and we can start with the expression that at any instant we can take the product of mass and velocity as constant. So, let us start from there. So, if we have m into v as constant, m is the instantaneous mass, v is the instantaneous velocity, and if this is constant, so we have its derivative as 0. So, if I take derivative of this, we get dm by dt into v plus m into dv by dt as 0, and that gives us the expression for the acceleration dv by dt as minus of dm by dt into v, and of course the m will also come in the denominator. So, let us put m here. This is the expression for the acceleration. Now, if we look at the question, the dm by dt in fact is given as bv square. So, let us put it here, and if we put it as bv square, then the expression becomes minus of bvq divided by m. That is the expression for the instantaneous acceleration at an instant when its mass is m and its velocity is v. If we look at the options, well, we can see that it is clearly matching with the third option. So, for this question, third option is the correct one. Let us go to question number 2 now. Question 2 says a ring is hung on a nail. It can oscillate without slipping or sliding in its plane with a time period t1 and 2 back and forth in a direction perpendicular to its plane with a period t2. What is the ratio t1 by t2? Well, it is from the topic oscillations, and basically we have physical pendulum here. So, what is the expression for the time period for a physical pendulum? The expression is t equals the time period t equals 2 pi under root of I divided by m into g into d. That is the expression. I is the moment of inertia about the axis about which it is oscillating, and d is the distance of the center of mass from the point of suspension. So, in the first case, the ring is oscillating in its own plane, and in that case the moment of inertia is given as mr square plus mr square using the parallel axis theorem. So, in the first case the moment of inertia is 2 mr square. So, we have I1 as 2 mr square, of course d remains r. In the second case, when the ring is oscillating perpendicular to its plane, well, in that case the moment of inertia becomes mr square by 2 plus mr square. Let me show it here. If this is the ring and this is the axis about which it is made to oscillate in the second case, okay. So, it is going like this perpendicular to its plane. So, to find moment of inertia about this axis, we start with moment of inertia about a diameter. For a ring, the moment of inertia about the diameter is mr square by 2 plus mr square. So, we get moment of inertia about this axis as 3 by 2 mr square. So, let me put it here. I2 is equal to 3 by 2 mr square, and Now we can see from here, since d is same and other quantities are same for the two oscillations, so the ratio of the time period is in fact same as the ratio of the moments of inertia, right, but we have to take square root. In fact, let me put it this way, that the time period is directly proportional to root I, which means T2 by T1, that is what we are supposed to find. In fact, we are supposed to find T1 by T2. So, T1 by T2 is given as root of I1 by I2. We already have I1 and I2. Well, this comes out as 2 divided by root 3. Let us now check the options, and if we check the options, well, option 2 is matching with our solution. Let us go to question number 3 now. Question 3 says the quantities x, which is 1 by root mu naught into epsilon naught, y, which is E divided by B, and z, which is L divided by CR, are defined where C is capacitance, R is resistance, and L is length. E is the electric field, B is the magnetic field, epsilon naught, mu naught are free space, permittivity and permeability respectively. All standard notations have been used only. Okay. So, we have to compare the dimensions of quantities x, y and z. Well, we can say that the question is from the topic units and measurement, it is about dimensions, but the quantities, this quantity we come across in the topic electromagnetic wave, we know that this is in fact equal to the speed of light in vacuum. So, x is speed of light in vacuum. What about y? Y is E divided by B. Again in the same topic electromagnetic wave, we know that the magnetic field oscillation amplitude is given as E divided by C, where E is the electric field amplitude of oscillation. That means E by B also has the same dimensions as that of speed or velocity. So, this is speed of light anyway, this is also having dimensions of speed. And what about Z? Well, we know that CR or RC is nothing but time constant of an RC circuit. That is how the expression is given. So, the unit of RC is second. So, dimensionally it is same as time. L by time in fact it has the same dimensions as that of velocity. So, that means all three quantities x, y and z have same dimensions, and that dimensional formula will be LT minus 1. So, if we now look at the options, well, option 3 says x, y and z have the same dimension. So, option 3 is correct for this particular question. Let us now go to question number 4.